All right, ladies and gentlemen, we are going to continue our adventure in Module 3 and complete Lesson 32 today. This is video 1 going over problem number 1 that I'm going to walk you through and talk you through my thinking on. Our goal for this lesson is to interpret and find whole number quotients and remainders to solve one-step division word problems. One step. But our divisor is going to be a number that might be a little bit more challenging. We're looking at divisors of 6, 7, 8, and 9 today. So we're going to talk about some methods and strategies when our divisor is a number is big that we haven't necessarily worked with as much and apply it to these one-step word problems. So take a look at this first problem we are going to work with today. There are 7 days in a week. 7 days in a week. How many weeks are in 259 days? So I'm like, okay, it's reminding me there's 7 days in a week. That's just a reminder. We know that now as fourth graders. The question is, if I am looking at 259 days total, how many weeks would that equal? So I'm thinking to myself, do I know the size of the group or do I know the number of groups at this point? Think to yourself, do I know the size of the group or do I know the number of groups? I have my tape diagram. I know my whole is going to represent 259 days. And I'm thinking, are my parts? Do I know how many parts I have or just how many is going to be in each one? I'm thinking, I know 7 days are in a week, but I don't know how many weeks it's going to take to get to 259 days. So at this point, I do not know the number of groups. I only know the size of the group. And that's okay. It just kind of helps put in perspective for me of what I'm trying to find, and it demonstrates that I understand what the problem is asking of me. So at this point, I'm going to continue in the RDW process and work on dividing these numbers. I need to take 259 days and divide it by 7 days each week to figure out how many weeks that is going to be. So I'm going to go ahead and set up my page for division. So I have 7 days in a week for 259 days. I'm going to use partial quotients to solve this problem. You're welcome to try partial quotients along with me. Otherwise, you're also welcome to use the standard algorithm. I'm going to use this to get us a little bit more practice. As I use partial quotients, I want you to think about our HTO chart and how I'm slowly taking away from this whole as I start using partial quotients on the side. So I'm thinking about 259 as individual days rather than in groups of hundreds, tens, and ones. I'm thinking of it as just 259 individual days that I'm ready to group into sevens as quickly as I can. Notice how I really have to know my multiples and my fast facts for 7. So I'm thinking, okay, 7 into 200, 250. Wait a second. I know that 7 times 3 is 21, which means 7 times 30 is 210. That's a big chunk I can take away. So if I say I can take 30 into groups, that takes 210 days and starts grouping them into weeks. And then have a remaining of 49 days that I need to group into 7-day weeks. So now I think, wait a second, 49? That sounds familiar. I know that 7 times 7 is 49. And when I do that, I end up grouping the remaining part of those days. And in total, when I think about how many weeks I ended up grouping, my answer becomes 37. So notice how I started by first taking away in blue here into 30, 210. Then I had 49 remaining. And I ended up regrouping that rest of my number. So I'm going to go ahead and check my work because I know these work in opposite of each other, and I should be able to take 37 times 7 and get 259. 7 times 7 is 49. I carry the 4. 7 times 3 is 21. Plus 4 more is 250. Check and mate. I can go ahead and write my complete statement, that last part of solving a word problem, and go ahead and write there are 37 weeks and 259 days. If you moved ahead, did you get the same answer as me? If you worked with me, did you follow along in those steps? If you were able to get 37 using the standard algorithm or partial quotients, that's great. I'm going to go ahead now and demonstrate this problem with the standard algorithm for those of you that prefer that method. So remember, when we are using the standard algorithm, we look at it as place values. So I think to myself, can I take 200s and divide them into 7 groups? Can I do 200s divided by 7? No way, Jose. When I do 200s divided by 7, I group no hundreds. And no hundreds times 7 equals just no hundreds, which is why I add my 0 here. And 2 minus 0 becomes a 2. Now I know when I'm thinking about it in a place value chart, I don't just leave those 200s there and go, oh, well, I unbundle and carry them over into the tens place. So now I have 25 tens divided by 7. I'm thinking about my facts. 25 tens. Well, I know that if I do 7 times 3 tens, that would get me 21 tens. I know I can't go over because if I think about my facts, then it would be 7 times 4 tens would get me 28. So I'm going to stop at 3. 7 times 3 tens equals 24 tens, or 21 tens, my apologies. 21 tens, and leaves me with 4 tens remaining. I don't just leave them there. No way, Jose. I go ahead and unbundle them into 49 ones all together. Now I'm thinking to myself, 49 ones divided by 7 would get me 7 ones in each group, because 7 ones times 7 equals 49 ones. I have nothing left to group, and just as I solved this with partial quotients, I got the same answer with the work I already checked. 37 times 7 is indeed 259.